session we shall understand what are the concurrency problems. In the last class we understood what is concurrency, what is concurrency control, transaction. Now, in this class we shall understand what are the possible problems with the concurrency. There are three noticeable problems. One is lost update problem. Another one is inconsistent read problem, and the third one is phantom phenomenon. So, during consistency, because millions or billions of transactions take place simultaneously at the same time, there is a possibility of occurring these three problems. One is lost update problem, the second one is inconsistent read problem, and the third one is phantom phenomenon. In the last session we also understood what is schedule and serializability. I would like to recall you what is schedule. The schedule is the order of execution of different statements. The order of execution of different statements is the schedule. There might be factorial of n schedules, but all schedules does not give the correct result, only few of them give the correct results. So, those schedules that give us the correct result, correct output, that maintains the consistency of the database, is said to be the serializable schedule. So, when we write schedules, that is when our processor executes different statements, if the order is not correct, it means if the schedule is not correct, then there is a possibility of having these three problems. One is lost update problem, the second one is inconsistent read problem, and the third one is phantom phenomenon. So, we shall understand what is lost update problem. Say this is transaction 1 and this is transaction 2. Now, the transaction 1 has to add 100 into A. Whatever the value of A is, the transaction 1 has to add 100, whereas the transaction T2 has to minus 50, has to subtract 50 from the value of A. Suppose the initial value of A is 200. So, A has, transaction T1 has to add 100 into A, that is the value should be 300, whereas whatever the value of A is, the transaction T2 has to subtract 50 from A. So, if the initial value of A is 200, then this should show 150 as the result. So, suppose this is the purchase and this is the sale, and the total stock value is say initially 200 and both the transactions take place simultaneously. So, suppose T1 reads A, then processor executes read A of transaction T2, and then A is equal to A minus 50. Now it writes A to the secondary memory, and then processor come back to T1, and here A is equal to A plus 100, and then write A. So, what would happen now? Initial value of A is say 200. So, when T1 reads A, the value of A for the T1 is 200. Then transaction T2 reads the value of A. So, value for transaction T2 is 200. Now, A is made 150 by subtracting 50 from 200. Now, transaction T2 writes A to the secondary memory, and the value written to the secondary memory becomes 150. Value written to the secondary memory becomes 150. After executing this, processor comes to transaction T1. Here the value of A is, what is the value of A? Whether it is 200 or 150. The value for A for T1 would be 200. Why so? Why not 150? Because transaction T1 reads the value from the secondary memory before writing this value by transaction T2. So, the value for A in the memory is 200. So, here what would happen? This would become 300, and processor would go to the secondary memory and would wipe out the value written by transaction T2, and then it will write 300. So, the final value of A would be 300. So, now see here, what should be the exact stock position? 150 plus 100, 250. The exact value for A should be, if both the transactions take place, the correct value of A should be 250, but your computer would be showing 300. 300 is an incorrect value, and it shows as if this transaction didn't take place. It shows as if this transaction didn't take place, and the value whatever is calculated by transaction T1 is written into the secondary memory as 300. So, what happens? The updates made by this transaction T2 is overwritten by this transaction T1. Means the updates made by T2 is lost. That is why it is called lost update problem. Okay? We can write it this schedule in another way also. Say here it is A is equal to A plus 100. Now, T2, for T2 read A, then write A. Here comes A is equal to A minus 50, and then write A. Now, what would be the final value in this case? See here, the value read by transaction T1 would be 200. Okay. Now, after this statement, the value for A in the main memory would be 300. Then processor comes to T2, reads A, and now here A is read as 200. Okay. Then processor comes back to T1 and writes 300 into the secondary memory. After this, processor comes to T2 and calculates A as 150 and writes it. So, say this is the secondary memory and here it is written 300 by transaction T1. Now, what would happen after this? After executing this statement, this value would be wiped out by transaction T1, T2, and here it would write 150. So, in this case, what happened? The value, the update made by T1, the value written by transaction T1 is overwritten by transaction T2, means the update made by T1 has been lost by transaction T2. This problem is known as lost update problem. The remedy we would see in the next classes, but this is the problem that occurs with the concurrency. Now, see the phantom phenomenon. What is phantom phenomenon? Phantom means virtual, that doesn't exist really. हिंदी में इसको हम लोग भूत कहते हैं, बैताल. So, what is phantom phenomenon? Say there are two transactions T1 and T2.